Unit 9, Day 2, exponential functions. We're going to be graphing some exponential functions in this set of notes here. So an exponential function is a function where the base is a constant, so the base is a number, and the exponent is a variable. So some examples of exponential functions right here, like y equals 2 to the x, y equals 1/2 to the x, right? So all these are exponential functions. To graph an exponential function, a lot of times it's just easiest to make an xy table and plot those points, right? So that's what we're going to do. We're going to take advantage of our calculator, all those things, right? So to graph these exponential functions, right, we got these x values, so we're going to graph y to the 2x. So if we fill in this table here, it's giving us x is -2. So if we take 2 to the -2, again, calculator, it's going to give us 0.25. And we keep rolling down here, right? 2 to the -1 is 0.5. Keep rolling. 2 to the 0 is 1. 2 to the first is 2. And then 2 squared is 4. So to graph these things, we have the order pair -2, 0.25, right? So -2, zoom in here, 0.25, right? Again, these decimals aren't going to be perfect, so just kind of put it in an area. And then we got -1, 0.5, so -1.5, and then 0, 1, 1, 2, and 2, 4, okay? So what we have to be aware of here is these exponential functions, this is actually never going to get to 0. It's never going to cross 0. So it's going to get really close to that x-axis, but it's never going to actually touch it or cross it. So we have this thing in here we put. Favorite word in math, this is an asymptote. Okay, and an asymptote is a line that your graph is going to get infinitely close to, but it's never going to actually touch it or cross it. Okay, so in this case, right, these exponential functions are going to have asymptotes, and that asymptote can be moved around if the function is transformed a bit, okay, which we'll see in some other examples here. Okay, but in this case, number 2, same deal. This time we're going to graph 1/2 to the x. So if we use these same thing here, right? So 1/2 to the -2, again, use that calculator. That's going to give you 4. 1/2 to the -1st is going to give you 2. 1/2 to the 0 is going to give you 1. 1/2 to the first is just a half, right? And then if you want to think about it as a decimal, which is 0.5, and then 1/2 to the second is 1/4, which is a decimal, 0.25, right? So if we graph -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4, right? And again, this is going to be the same type of thing here. So this is going to get really close to 0, but it's never going to actually touch it or cross it, okay? So we should see something like that. So again, these things are going to have these asymptotes, okay? So as we look at these transformed functions, okay, we're going to see stuff like this right here. Y equals a times b to the x minus h plus k. So just like we've seen in all these other types of functions before, this value of h is going to shift things left or right. And then k is going to shift things up or down. And then that a value is going to stretch, shrink, or reflect our graph. If it's a negative, it'll reflect it, okay? But when we talk about domain and range of these things, the domain of these exponential functions is always going to be -infinity to infinity, right? You can put whatever x value you want on these things with no problem. The range is going to depend on the value of k, so if it's been shifted up or down, and then which direction it opens. So if it opens up, it opens down. That's going to change our range a bit, okay? But one of the important things in here is the equation of that horizontal asymptote is y equals k. So k also determines where our horizontal asymptote is going to be, right? So as we look at these guys, when they've been transformed a bit, right? In this thing, we've got a, h, and k. So our a value is 3, h is positive 4, and k is positive 3. So as far as our asymptote goes, right, remember that's y equals k. So our asymptote is y equals 3. Okay? So we can go ahead and put that on there. Y equals 3 is a horizontal line through 3. Right? There's our asymptote. And then to graph, right, we're going to do the same thing we did up top. So this time we've got some different x values to plug in. So we're going to plug in 0. So 3 times 2 to the 0 minus 4 plus 3. Okay? And if we, again, use your calculator, that's going to give us 3.1875, right? And then same deal here, plug in 1. 3 times 2 to the 1 minus 4 plus 3. That's going to give us 3.375. And then if we plug in 2, that's going to give us 3.75. Plug in 3. It gives us 4.5. And then plug in 4. That gives us 6. So again, I know decimals are not going to be perfect on your graph, but we're going to graph 0, 3.1875. So 0, and just a touch over 3. And then 1, 3.375. So 1, and then just a bit above that last dot. 2, 3.75. So 2, and then a little bit higher there. 3, 4.5. So 3, and then halfway between 4 and 5. And then 4, 6. So should see something like this. And then now this thing's not going to go below that y equals 3 because everything's been shifted up those 3 units. So as far as our domain goes, again, the domain's going to be the same for every single one of these. So free points on a quiz or test for that domain. And then your range, we go lowest to highest. So the lowest this thing's going to go is it's going to get really, really close to 3, but it's never going to actually touch 3. So we say it gets really close to 3, but it doesn't actually touch it, so we put parentheses there, and then it's going up towards positive infinity. Okay? So that's what we're working with there. Same thing for 4, right? So if we, again, identify A, H, and K. So A is that negative in front, so -1. H, right, x minus h. There's no h up there, so that makes h 0. And then K is -5. So again, your asymptote, y equals K. So y equals -5 is our asymptote. So we go ahead and put that on there if we want. So horizontal line through -5. And then we need to find our points. So we plug in these x values. So 3 to the -2 minus 5. Use that calculator again. That's going to give us -5.1 repeating. If we plug in -1, that's going to give us -5.3 repeating. Plug in 0. That's going to give us -6. We plug in 1. That's going to give us -8. And if we plug in 2, That's going to give us negative 14. Okay? So, plot these points. Negative 2, comma, negative 5.1 repeating. So, negative 2, and then just a touch below negative 5. Negative 1, negative 5.3 repeating. So, again, just a touch below that. 0, negative 6. 1, negative 8. And then 2, negative 14 won't fit on that graph, so we'll just leave it off there. But again, now we can see it's kind of shaped going this way. Now, this thing, again, is never going to actually touch that y equals negative 5. It's going to get close to it, but not touch it. So again, domain free points, always the same for these exponential functions. And then our range, the lowest this thing's going is going down forever. So it's starting from negative infinity. And then it's going up to that negative 5, getting super close to it, but not going to touch it. All right? So that's how we're going to graph these things. With these exponential functions, right, we call these things exponential growth or exponential decay, depending on if it's growing or if it's getting smaller as we go in the x direction, in the positive x direction. So we can either look at a graph of it to figure it out, or we can just look at the base. So if the base is greater than 1, then that function is exponential growth. If the base is between 0 and 1, meaning it's a fraction, then that is exponential decay. So if we look at this, right, to figure out these are exponential growth or decay, in this case, our base, the thing being raised to the exponent, is 3 over 4. Okay, so 3/4. So 3/4, our base then is smaller than 1, bigger than 0. So it's between 0 and 1. So this thing is decay. It's going to be getting smaller. If we look at 6, our base this time, right, the thing being raised to the exponent is 5, and that is bigger than 1. So that would make this thing growth. All right, so that's how we're going to graph exponential functions, all that stuff. So take advantage of that calculator. Try out your homework. Let us know if you have any questions.